Hello everyone, I am Parneet Kaur. Here in this video, I am going to discuss what I have done in my MA thesis. I did research on Shilling attack detection in recommender system. In this presentation, I will be covering introduction, literature survey, objectives and problem statement, work done by us in our thesis, its conclusion and references. First of all, start with the introduction. What is recommender system? It is an application which helps users to select relevant products from millions of choices available on the internet. But the recommender systems which are based on collaborative filtering approach are vulnerable to shilling attacks because in this system predicts the ratings for the new user based on the feedback of similar users. Shilling attack is also known as profile injection attack. In this, attacker creates a large number of attack profiles and inject them into the system's database, which may alter the result. The main motive of the attacker is to promote his or her item or demote the opponent's item. There are some efforts which are required by attacker to mount an attack. First one is knowledge needed about the system. The attack can be high knowledge attack or low knowledge attack. In high knowledge attack, there is a requirement that attacker must be knowing the details of the system, but it is not true in the case of low knowledge attack. The second effort which is required is the number of profiles and ratings added into the system's database to make that attack effective. Basically, there are two types of attack: push attack and nuke attack. Push attack is used to promote the items, whereas nuke attack is used to demote the opponent's item. In this, various types of attack models are used by attackers to create the attack profiles. Some of them are random attack model, average, bandwagon, or segment attack model. These are the attack models which are used in the case of push attack. The attacker's profile is categorized into four subcategories. First one is IF, which denotes the set of filler items. IS denotes the set of selected items, and IT is the set of targeted items. IN is the items which are not yet rated by the user. In random attack model, overall mean rating is given to the items in IF set and maximum rating is given to the target items in case of push attacks, and minimum rating is given to the target items in case of nuke attacks. In average attack model, individual mean rating is given to the items in the IF set. Similarly, as in the case of random attack, maximum and minimum rating is given to the items in the push and nuke attack respectively. Same is the case with bandwagon and the segment attack. Now, there is a requirement to distinguish the attack profiles from the genuine users. This can be detected using various classification techniques. For this, a training set is created to train a classifier so that we will be able to distinguish between the malicious profiles and the genuine profiles. First of all, detection attributes are created. Detection attributes can be of two types: generic attribute and model specific attributes, which are created to find the features of a particular attack models. These are some general attributes: RDMA, WDMA, TechSim, WDA, and length variance, which are first generated and used to detect the malicious profiles. Now, these are some model specific attributes. Main variance is an attribute which is used to detect the average attacks. Filler mean target difference is used to detect the bandwagon attacks. To measure the performance of the classifiers, recall, precision, and F-measure metrics are used. This is a literature survey. These are some uh, research papers which I have read and concluded what the researchers have done till now. Now, what are the objectives and the problem statement is the main objective is to deal with the Shilling attack. There are some issues which need to be addressed. First one is to test the stability and robustness of the recommender system after the attack. Second is to check the possibility for a malicious user to mount various types of attacks. Then to identify the profiles of the attackers. Another objective is to test the performance of the classifiers which are used to detect the fictitious profiles. The last one is to promote the accuracy of the predictive models used to detect the attack profiles. Our main motive is to detect the malicious profiles from the genuine profiles. This is the proposed approach which is used to measure the stability of the system. In this, there are some actual users and attackers who generated the fictitious profiles. Then, similarity between the users are calculated using Pearson's correlation and predict the ratings for the target users using KNN algorithm. Then top and recommendation is used to for the predicted results, and then the stability of the system is measured using the prediction shift. Now there is a need to detect the profiles, so we have used classification techniques. First of all, data pre-processing is done. Then we generated the detection attributes. The detection attributes, the training set which includes the detection attributes is of the form it contains user ID, detection attributes and the label whether it is a genuine profile or it is a fake profile. Then some classification techniques were used to distinguish the actual and the fake profiles. Then the performance of the classifiers were evaluated on the basis of precision, recall and F-measure. We validated our result using cross-validation. Then we assembled the best two performers and again we evaluated their performances. This is how we implement our results. We performed our experiments on publicly available movie lens dataset. In this, 1 to 5 rating is given to the items. 1 means the most unfavorable items. 5 means the favorable items. In this, we randomly select the 50 movies and 63 users from the whole dataset. Then we implemented attack models to mount these attacks. Prediction shift is used for the effectiveness of the attack. Then the training set is created by selecting the set of profiles from this database and label them as a genuine. Similarly, we mix the attacker's data into the system's database at various attack sizes and filler sizes and label them as a fake. Then detection attributes were created. This is how the structure of the training set is. Attribute 1, attribute 2 up to attribute n. The classifiers which we have used is random forest, naive Bayes J48, 0R, radial basis function network in the in Weka. Then K-fold cross-validation technique is used to estimate the predictive models. Their performance is analyzed on the basis of recall, precision, and F-measure. Out of them, we analyzed the naive Bayes and random forest are the best performance. So we integrated that models into one model using a majority voting method. These are the results which we have analyzed. This is a graph which shows that average attack is the most effective attack. It has the highest impact in item-based collaborative filtering approach. Similarly, this graph shows that average attack has more impact on the items in user-based collaborative filtering. From this figure, we can conclude that user-based collaborative filtering approach is more vulnerable to these attacks. This is a comparison of in-segment attack in between user-based and the item-based attack. From here, we can conclude that item-based attack is more secure than user-based CF approach. These are the classification results which we came across. This is a performance analysis of models for bandwagon attacks at 50% filler sizes. From here, we can see that naive Bayes and the random forest are performing well in many cases. This is the results in performance analysis of models for average attack at 50% filler size. Similarly, this is for bandwagon attack at 25% attack size. This is the same in case of average attack. And this is what we got is we improved the accuracy of the ensembled random forest model. We have used a Weka experimenter. Here you can see that the ADA boosting random forest has improved accuracy as compared to the simple random forest. You can see here it is 100% accuracy, but here is a star, which means it is significantly important, and without star it means it is meaningless. From this, we can conclude that average attack has the highest impact on the recommender system, but it is less effective against item-based algorithm. Therefore, we can say that item-based collaborative filtering systems have higher security than user-based collaborative systems. We generated various detection attributes to detect these attack profiles. Then we used some classifiers to distinguish them, and the best performance were integrated to produce a novel model. And we have improved the accuracy of integrated random forest model. These are the references which I referred and implement our results. Thank you.